Good morning, everyone. Great to see you online for the first of our summer sessions. I'm Maxine Fakara, PraxisAuril CEO, and it's my pleasure to welcome you to the first of 3 webinars that we're running today with our colleagues from Jisc. So a few housekeeping points before we start. We've got participant video and sound turned off to preserve bandwidth, and we'll be using the chat function to log your questions. So I'll be keeping track of all your questions. Just send them in as you think of them. Please remember to note your full name and organisation when you ask a question, especially if your Zoom account is a personal one. If you're having difficulties with anything on the call, then you can also use the private chat function to contact the PraxisAuril meeting host. Just to remind you too that we are recording this session and it will be made available after the event to PraxisAuril members. So today we've got some interesting sessions lined up for you. This first one about cloud technology, and then later today embracing the full potential of open access as well as cyber attacks on research and innovation. Sounds very interesting. I'm sure I'm going to learn loads. So let's get started. It's my pleasure now to introduce Caitlin Bloom. She's Senior Business Development Manager, Industry Research from Jisc, and she's going to chair the session for us today. And you'll also see on screen Christian Evans. He's the Customer Director, Public Sector and Industry Research, and he'll be involved with all the sessions today too. So Caitlin, over to you to introduce Colin Blake.
Hello, good morning everyone. So just before I do introduce Colin, I just thought I'd give you a very brief overview of Jisc in case you are not heard of us before. So we have the National Education and Research Network across the UK called Janet, and we link into America through Internet 2 and Europe through Géant. So we work with some really big companies in the industry research environment, including Syngenta and BAE, and we connect all universities in the UK and some of their industry partners. So we specialise in cloud, cyber and connectivity, which is why I would like to introduce Colin to give you an overview of cloud technologies and an insight into what Jisc does specifically in this space. So over to you, Colin.
Morning, everybody. My name is Colin Blake. I'll just share my screen 2 seconds. Can you see my slides?
Not yet. They're just
2 seconds. Oh, there we go.
There we go.
All right, apologies for that. Yes, so I am here to just give you a brief overview of cloud technologies, some key definitions within the technology and how we can implement some strategies to manage those technologies to make sure your organizations get the most out of it. I'll give you a quick overview of myself. Yeah, as I say, my name's Colin. I've been working in the IT industry over 20 years. For a vast majority of that, I was a network server guy. I worked large projects in public sector and private practice. And it was during one of these projects at a large police force that I was first forced to work with cloud, really, in the form of Azure. And it was whilst working through this large scale project to bring technology together on premises and in the cloud that I had this sudden realization that cloud technology was very much the future of my business and industry. And as such, I made the change then to come over to the cloud technologies through Jisc, and I'm very much an evangelist of cloud technologies. I understand the limitations of it, but I think with a well thought out structure, strategy and process of change management, cloud technologies can really meet many of the needs that people have today. Within Jisc, we have the Jisc Cloud Services team. We operate with GCP, Azure and AWS. We have architectural and engineering teams for all 3 cloud providers, and a key part of our role is to meet with customers and identify where they have difficulties or pinch points and try and marry up technology then to address those so that then they're more able to operate towards their business outcomes. Just before I continue, this, as I said, this is a very high level overview of what's going on, and maybe a little bit too high level for some of the attendees here, but do feel free to ask questions towards the end or through chats during the process, and then I'll be able to dive more deeply into any issues that you have or questions. As I say, it is very high level, but feel free to reach out to us either during this session or afterwards, and we'll be happy to try and help answer any questions you have. So the traditional on-premise system is the data center that we all know and love, that we've worked with for many years. It's the air-conditioned, network redundant, power redundant room that we have all our kit in. It's a large expense. You have to keep on top of it with regards to having a CapEx model, which is within your hardware cycles to replace, software cycles. It's the large investment that you have within your organization. But married up to that is the ICT support team. They work and know this system intimately. You have the skill set necessary to run with it, and as an organization, you have been very much married up your abilities and requirements to the on-premises. But unfortunately, over time, there is an expectation that as business needs change and a pace of change is increasing, that maybe the more static model of a 5-year cycle isn't really going to be relevant going forward, and you have to have the opportunity to be able to move quickly when business opportunities arise, or changes, or risks even. Moving on from there, then you have what's known as the private cloud. This is essentially a shared set of resources, compute, network, storage, and it's made available to the consumers within an organization. This may be a private cloud like a system center or a hyper-converged environment. So this would mean then effectively you have resources in a pool and you would draw down on them as load requires. This is a model that was becoming particularly prevalent in the noughties and towards the 2010s, and people were seeing real benefit from that because it gave them the flexibility that the previous hardware model didn't have, where you'd make investments and be tied into that for a set period of time. You could make an investment in hardware, but then be a little bit more flexible in your workloads. But even this over time then is still, you're in the same cycle of renewal and having then the dependencies on physical infrastructure within your environment, and then the vagrancies of a JCB digging up your fiber link outside your data room, and you're losing all connectivity. So people then started looking at then the public cloud. So the public cloud is often what people think of when you hear cloud. So we're talking about the big players here. It's AWS, Amazon Web Services, Google Cloud Platform, and Azure from Microsoft. There are a large number of other cloud providers, Oracle, Alibaba, and many, many more. But the massive market share is taken up by those 3 lead players. It's a flexible hyperscale environment. You essentially have a vast array of resources that are available for you to purchase, and then you can buy them on a per second basis, all the way through to making reserved instances, reserved cash purchases for up to 3 years at a time. And these will give you reduced costs, but you are committing then to making those investments over that period of time. And then finally, as a model, we have the hybrid cloud. It's a bit of a busy slide, but there's a lot of information there. So hybrid is specifically talking about managing a public and private cloud as one, but that term over time has morphed into effectively having an on-premise environment of some sorts and a cloud environment of some sorts, whether you have burstable extendability from your on-premises into the cloud or completely isolated workloads. Many people just say hybrid now, so you can get a little hung up on terminology, but everyone uses the same term. When they say hybrid, they mean a presence in both camps. In my experience, this is a model that most people will be working with, because people have made large investments, particularly around software. They might have a monolithic application or service that's sat there that just doesn't lend itself to cloud technologies. And as such, the technical debt within that means that their whole business and organization is centered around it. And to pull that apart and try and move it to the cloud is simply not feasible. So expensive, so complex, and so full of risk that it's just not worth it. So what we are seeing is a lot of people are then, for instance, moving some workloads to the cloud, and any new workloads are deployed in the cloud, but slowly but surely then the older stateful applications, these sort of older technology and architectural structures are being whittled away until they're getting smaller and smaller. It may well be at some point there'll be a tipping point where the cost of running an on-premise environment for your last large monolithic applications is so expensive that you may then make the leap to either purchase something new or design some new environments that you can work from there. Okay, so now we're talking about IaaS, PaaS, serverless or FaaS. So lots of acronyms, but we'll run through them now and give you an understanding of how they work. These are the technologies within cloud and how you broadly divide them. So IaaS, infrastructure as service. This is essentially the same as your data center that you've got down the corridor at the moment that you've been using for the past 10 years or so. You have a set of resources with a virtualized environment on there. So VMware, Hyper-V Farm or similar. You have a compute cluster, which is then sat on top of networking and storage, and essentially you just use the resources there and allocate them as you require them. The key difference with infrastructure as a service within the cloud is that you're paying on a billing process of as short as per second. So for instance, you might have workloads that are dev tests. You can mark them to be shut down from outside the period of 8 in the morning till 6 in the evening, so outside core business hours. That effectively would mean then that you would only be paying for them being up 40% of the time, and then you make a large saving there. This is a model that many people use initially when they move to the cloud, because they look to move stuff from their data center into the cloud. But the investment here can be seen as expensive because you can sweat your assets much more on premises, because you can have a higher concentration. You can keep running servers beyond their support window if you want to, and that can drive down costs of ownership over time. But obviously then you open yourself up to potential support issues, sudden hardware failure, and then trying to get that replaced. When you move to IaaS, it's quite often seen as the first migration that you're going to do in the cloud, because then you look to move up the cloud stack then to move towards, for instance, PaaS, platform as a service. So using the abstraction of the shared responsibility model, in the previous model, the cloud providers would look after the power, the cooling, the virtualization, the physical security of all your kit, and then you would be responsible for everything above that from the OS level up. With the PaaS, you abstract the operating service layer, so you then hand that responsibility over to the cloud provider, and you just look after the information that's been housed on it. A key example of this would be Azure SQL or any database workload in the cloud. Instead of worrying about running the SQL server itself and making sure it's connected and what have you, you just worry about the actual DBA, the database administrator actions, and making sure that your database is running at operational efficiency and that you've got good store procedures and everything's running well, but you just abstract all the other responsibility and admin overhead to the cloud provider. And also what it allows you to do is aggregate a lot of workloads. So you might have what's known as an elastic pool. So you might have a platform as a service SQL pool, and you have multiple SQL loads in there, and then that sort of stretches and flexes with the load as is required, and then that gives you greater flexibility then. So for instance, you might have key workloads that operate during business hours and key out of hours operations. If you put them into the same PaaS environment, it means then you get a more even 24-hour workload over the whole system, and that generates efficiencies, and so then you're more cost efficient. There's many others. There's Google App Engine and web apps, and there's as many services as you can imagine really in the cloud, and they're growing day by day. And so there's also then updates to all those services as well. It's a really difficult part of my job to keep on top of changes in developments and improvements in services. So it's something then that you need to keep an eye on if you're working in the cloud environments. The last key as a service that we cover, there are many more, and they seem to be coming out all the time, but we have serverless or function as a service. This is a true cloud native technology. So what will happen is you will what we call decouple dependencies. So instead of having a traditional 3-tier web application with database, application, or web front ends, you would push the web front end out to some web parts. You have the database would be set on a PaaS server, as we discussed before, and then the application could be running in a Lambda in AWS, or an application app engine in Google Cloud, for instance. And what would happen is as the different parts of the components of the platform are isolated from one another, they can recover from lost data, they can scale up or scale out as required, they can have queuing between the different services, and this is a true cloud native way to work. So if you were to build something brand new in the cloud, to get the most out of it, I would suggest that you would look to use functions and serverless. If you think Netflix is a cloud only infrastructure platform, and they work purely at this level. So, and they even have an application called the Chaos Monkey, which goes in and randomly switches things off, and they need to be able to recover from it. This is where you use automation, and you really get the key benefits from cloud is flexibility and scale. This is, as I say, it's, if you're developing something new in the cloud, you'd really want to look at this end of the stack rather than further down, because it just allows you to really get the benefits. I've tried to represent this in a bit of a diagram. It is a little bit clunky, but I think it does work. At the bottom here, we have repurchase. This is SaaS, which actually, sorry, I didn't cover it in there, but it's software as a service. I think everybody understands how that works. So think of things along the lines of Microsoft 365, Salesforce, and all these products that you essentially connect to through a web page, and you just operate in. The great advantage about them is they're really simple to migrate to. They don't take much effort to start using. I mean, if you want to start using Microsoft 365, you just put your name in and a credit card, and off you go. You're up and running. What you don't get is the real flexibility to work in a way that's really tailored to yourself. So you are being given a piece of software as a service, and you operate with that. The next step then is to rehost, which is a lift and shift. This would be moving to your IaaS platform. So this would be lifting your servers as is from your environment, bringing them up to the cloud, and just operating them in exactly the same way. This gives you a little bit more flexibility because you get to control from the operating system up, but the cost and overhead and admin management still remains, well, I'd say the admin management stays the same, but the cost may well be higher because you're having to obviously pay for the cost of operating on other people's hardware. The next one is re-platform. So this would be part of, for instance, moving a SQL server into a SQL PaaS. So you look to change how the data and platform is homed or hosted, and make a change there. And then finally we have refactor. So this is where you start from scratch. You look to design something from the ground up, or look to start pulling apart that large scale application that we discussed earlier and pulling it into separate decoupled dependencies, as I discussed before. Now the arrows here indicate that the fact that it's going to cost you more effort and skills and costs to try and move up the stack, and it's going to take you longer to migrate, but it could be argued, and I would argue, that you'll get more from your cloud deployment the further up this stack that you move. It's a key question of what is the appetite of change, what is the appetite to risk when doing any migration or change, and these factors need to be addressed and really identified. You really want to make sure you have a robust migration plan, a really good testing plan, that you're working in small sprints, which are defined short periods of work with clearly defined outcomes that can be tested, and you can have clear milestones against. And that's the whole process of doing a migration. And migrations are complex and difficult, and you want to make sure that the effort that you're making is borne out in having a resilient, cost-effective but efficient system at the end of it. So to that end, there's the well-architected framework. So this is a cloud concept, I suppose. It was first championed by AWS, and it was so good that Microsoft brought out their own one quite quickly afterwards. And they understand then that if you have some key criteria that you want to work around to make sure that you have an environment that works for you. So this is the experience of the large cloud providers. So they've had literally hundreds of thousands of workloads, and they've gone through it, and they've looked at areas where you have to make key decisions, and those where people have made key decisions that are well thought out, documented, and adhered to, you get a good cloud deployment, a well-architected framework. So in the first instance, we have operational excellence. So this would be like learning from operational failures. I spent a lot of time with AWS, with all the cloud providers in webinars, and they have a key tenet to their operational excellence is if you see the same error twice, you need to automate a response to it. So the idea is that over time that your system becomes resilient and self-healing. So people don't get woken up at 3 o'clock in the morning because a database has had an error reading. It's actually fixed itself, raised the ticket, added the details into it, emailed the relevant people, and everyone comes in on the Monday morning or whatever, looks at it and understands that it's worked well. Also, part of operational excellence, an example would be make frequent, small and reversible changes. Similar to the migration sprints, you want to make clearly define what a change should be. Understand how you're going to make that change and how you're going to test it and how you're going to roll back from it. A standard change requests and change management process, but small, iterative, high frequency changes lead to a better improvement in the cloud than large sine wave changes, which involve a massive amount of work to implement and roll back. The second part is security. I mean, everyone's concerned about security. We were discussing Garmin just before we came on. Nobody wants to be on the front page of the news, especially not the IT guys, because they've had a bit of a disaster. You need to implement a strong identity foundation. So you need to understand how you're going to manage identity, how you're going to manage access, auditing, the AAA, authorization, auditing, and accounting. A key tenets of understanding who's done what and if they have the correct credentials for it, and people have tried to do stuff that they haven't been authorized to do. Another key tenet of that would be protect the data in transit and in rest. So when you're got different parts of your platforms talking to each other, you need to have encryption between the two service points. That means that if anybody was to be able to tap the line or get a man in the middle, they wouldn't be able to access that data. And equally, once that the data's been processed and written down in some storage, you need to make sure that's encrypted as well. And these are using strong keys. For instance, a key management system that rolls the keys consistently so that you maintain that security. Reliability is a key example of that is automatically recover from a failure, as I discussed just a moment ago, and manage change through automation. So we hear a lot about DevOps. So DevOps is almost a philosophy, I suppose, in IT. Is you're meant to have multi skilled members in a team, and these teams operate in small chunks of work. So effectively, you'd have the application developer, you'd have the security guy, you'd have the tester, you'd have the marketing people, all working together side by side, so they'd all know what they were doing and have an understanding. They wouldn't be siloed from one another. And then these teams come together and they make sure that they test, manage the change, do the tests, update everyone, and they do it through automation. And this way it stops the possibility of human error. Performance efficiency, as I said earlier, was about using serverless architectures, really breaking apart the different components of a platform to the smallest possible constituent parts. There's many applications out in the cloud now which they run only when they're required, and you only pay when they get run. So really spiky workloads are a key part of that. So if you had for instance, at universities, admission time and clearing. There's a massive amount of workload that people have to get through, and this would, but then through the rest of the year, it's not really used. So that's a term we call overcapacity. So if you had a serverless function environment, you would be paying for the workload as and when it was required, but for the rest of the years, effectively, it would be just sat there doing nothing and wouldn't be costing you anything. And then cost optimization. So use managed services to reduce cost of ownership. It's a tricky one to quantify that, really, because managed services costs more in a purely sort of licensing model, but you really have to look at the total cost of ownership of having an environment in on-prem. So you have your tin, which you need to buy, you have your electric, you have the cooling, you have the licensing for the server, for the actual software. You have to pay for the person, the admin looking after it, the guy who does the tapes, and then the off-site storage, the guy who comes to pick that up. And all these different costs are quite often not taken into account when you're looking at the cost of having an environment on premises. Now, these are soft figures, and it's quite hard to get a definitive cost on them. I know Forrester do some total economic impact of some providers, but I do find them a little bit optimistic in many ways, some of the cost savings you make. But I do believe that, you know, by freeing yourself up from having to look after the day-to-day of running IT allows people to come up with new ideas and new ways of working that could really have benefit to organizations. Another cost optimization then, where I finish on, would be measure overall efficiency. So you really need to wring as much as you can out of every pound you're spending. You don't want to have a whole load of spare capacity in the cloud because you'll be paying for it anyway. And people can quite often think, oh, well, we'll have a bit of headroom so that if we get any spike in workload, we can deal with it. You deal with spikes in the cloud through scaling out or scaling up, or having a decoupled architecture. It's not done in the traditional way of having a whole load of spare capacity which you pay for or not using. So how do you bring all this together? So I mean, there's quite a lot of information there, but we at Jisc have a concept. It's called a landing zone or a scaffolding or a framework, and what we like to do is we think before you use any cloud technologies, you really need to get this into place before you put any workloads into it, because once you have live workloads operating, it's really hard to retrofit this, and you might then miss something going backwards. Whereas if you make a key decision to get this clearly defined at the start, when you move forward, then it just cascades in. So for instance, we've got security, we discussed it. MFA, MFA is multi-factor authentication, having people just click on their phone when they want to confirm access. security in depth, using consolidating all your security into certain vendors. Are you going to use virtual appliances in the cloud? Are you going to use native tooling? All these things need to be identified and have a decision made upon them. Compliance, so ISO 27001 is a key one, UK official, NHS. So in Azure you have blueprints. These are a set of settings and criteria that you can apply to an environment, and it will go through the whole process then of making sure that you are operating in a way that would comply with the standards specified. In Microsoft 365, there's something as well called Compliance Manager, and in Jisc we use that to assign out the tasks that people need to do to make their Microsoft 365 environment secure. And the great thing about that is it has a clearly defined requirement. You can give it to somebody and specify a date for it to be completed, and it's a really quick way to just make sure that when somebody says, can you prove that you're compliant? You just go to this and say, yeah, we've done all this work on these days. These people did it, and we keep an eye on it on this and this sort of frequency. Tagging is a massive thing that's of huge benefit, but largely overlooked, I think. So you tag your resources. Who owns a resource? So you don't have to chase up people trying to figure out who owns this server that's been stood there but not been accessed for a long time. Is it dev or is it production? So can you shut it down outside of core office hours? Cost centers. You could then tag it either with some compliance then, so you'd be able to apply certain criteria to it, to the resource, based upon the tagging. So you can enforce tagging, so people can't build things without putting the necessary tags in. I think that's a key part of having a sound landing zone for your environment. Cost management. So then this is a follow-on then. So we look at workloads. Are you being efficient? Can you scale out, auto scale your environment? Can you shrink it? Are you making the most of, you can buy preemptible instances which are essentially spare workloads. So if you had, for instance, a batch process that could take being interrupted in the supply, you can buy these preemptible instances which are effectively overhead sort of spare capacity that the cloud providers have, and they sell you at a much cheaper price. I did read an article about a company that was doing it, and they called it follow the sun. So obviously workloads peak during office hours in the day, so at evening the workloads drop off and these preemptibles become available. This organization was following around the earth and then following as these preemptible prices hit a certain costs, they would move their workload from one region into the next to the next, and essentially they were following the cheap price, and so they were maximizing their savings on that. And at the other end of that then is reserved instances, where if you had like a line of business, heavy, consistent workload that was running at steady state, you could then reserve your instance for 3 years. You pay some upfront, but you get a reduced cost then over the life of the platform, and that's another key cost saving. Identity, as I discussed, is a key part of cloud identity and access management. You want to make sure the right people are connecting to the right services, that they are only accessing the information that they have rights to, and that the different key components are then your crown jewels effectively are being protected by making sure the right people are able to gain access. So once you have, I mean, this is just an example, but there are many more. So here at Jisc, we tend to go and see people. We have or we did, or now we do it virtually. We have a workshop where we identify your compliance needs, your identity needs, your security, and we effectively build this framework up for you. And then once you've got it in place, you can just drop in your workload, your database, and so long as it has the right tagging and it's in the correct area as defined by your organization, it'll pick up its identity, its compliance, security, and cost management just from being there. And then again, any other workload that you may put in. It's a rather crude representation of how it all works, but it is a key component, I think, to maintaining confidence in the cloud, because if you lose confidence, particularly early on in a transition, it dents it going forward, and it makes it really difficult then to recoup it. So as I said, I think this part of any cloud deployment or migration or strategy is really key, and the more effort that you put at this point will save you so much more grief further down the line, because you'll have everything in place. You have real visibility. You'll be having all the you'll be able to answer the key questions when people ask them of you. Okay. Any questions?
Just jump in here. That was fantastic. Thank you, Colin. It always blows my mind with the depth that the cloud can offer. I really like the follow the sun principle. I've not heard that before. I'd quite like to do that.
Yeah, sounds good.
It does, doesn't it? I'll follow the sun to Barbados any day. I also really like this curious monkey, and just wondered if you could explain a little bit more how the curious...
a chaos monkey.
Yeah, how does that work?
So we all know Netflix, and they're a huge organization, and everything that they operate is in the cloud and done at the serverless function level. And what they do is to test that their system is resilient. They have this chaos monkey, which is a piece of software that goes through their environment and just switches things off, changes IP addresses, and things like that. And then the idea is the environment should recognize that this is happening, record all the information, and self-heal in a way that it doesn't impact then customer viewing. And that's how they do their testing. I mean, it'd be heart-stopping, I think, to do it on any environment that wasn't built that way from the ground up. But
gosh, yeah, no, I don't fancy that one. And the other question I just wanted to ask before I throw it out to the floor, and if you could check the questions for me while I ask this one, that would be grand, is this hybrid model. When we're talking about TIN, we're talking about physical data centers or servers that a company or organization has on site. Yeah. Who looks after the stuff that's not on site?
So essentially, you are buying, if you go to the public cloud, you are buying TIN in the cloud, but you don't own it. So there's a shared responsibility model. I can follow up the call with some information on that. So essentially, with the TIN that you own in your premises, you're responsible for all layers of the stack. So physically, you need to make sure it's plugged in and has electricity, and then you have networking, and then you move your way up to sort of hardware and OS and what have you. As you move to the public clouds, the physical connectivity, the TIN, the electric and everything like that, and the physical security, making sure people can't get in, you hand that off to the cloud provider. Then as you move to PaaS, you hand off as well the operating system, because you're not looking after Windows or Linux or anything like that. And then as you hand it off then to serverless and functions, you hand it off then, you're abstracting it entirely. Basically, you just write a bit of code and then you throw that out of the cloud, and they look after everything other than that. And then, so that's essentially the furthest end of the shared responsibility model. But not everything will lend itself to moving up the model. So you might have like I speak a lot about SQL because I looked after it a lot in a previous life. But for instance, if you had a line of business SQL instance that had a specific configuration that needed to be done at the OS level, you couldn't move that out to PaaS because effectively you've abstracted the operating system off. So you have no control over it. You have no access to it. So in many ways, you lose controllability and configurability by moving up the stack, but you also lose the headache of looking after the kits, and so your responsibility diminishes, but so then does your flexibility and control.
When we're all now working remotely, I wouldn't like a switch to fail and not be able to see it. I quite like the idea of somebody else worrying if literally the lights are on. So leading on from that, on the kind of working remotely, we've had a question about what trends are we seeing now post-COVID with people not on sites and kind of everybody all over the place.
Specifically for myself, we've seen a massive uptake in Microsoft 365. So Microsoft 365 used to be Office 365, and they do like to change the names regularly to keep you on your toes. So Microsoft 365 now is the Office 365. You get your Windows 10 license for that, and you also get something called EM&S, which is Enterprise Mobility Security. So this is the modern workplace, you would say. So this is your device, your handheld, your office suite, and your teams, and how you communicate and how you share, how you secure that data, and how you make sure that the right people are accessing the right content. But this has had a massive uptake in the past 3 or 4 months, because obviously people are working from home. The file server back on premises isn't really accessible. It doesn't map very well to people's environments. People are connecting through on VPNs, but the problem is they may not have a device, a work supplied device that's secure enough to connect to it. And what's happening is people are using VPNs, they're opening the stuff on the file server, but they're bringing it down to their local machine. Now, effectively, that has now left your environment. You no longer have control of it. It's in the wild. If that has a load of information on it, you could be then liable for that being leakage, for having data leakage. People obviously don't do this on purpose, but it's just people do it by mistake. It's easier to work locally because they might have a bit of a dodgy connection or something like that. When you move towards the Microsoft 365 end of the spectrum, effectively all the security, instead of being on the edge where the person's VPN was coming in, it's the actual piece of data itself, the spreadsheet or the Word document has the security on it. So whether you access it in Windows, on your laptop, or on your phone, or anywhere else, the security is applied based on your identity, which we discussed previously. So I've seen a massive uptake on that, because it just means that people can be confident that regardless of the method of connection and the device that they use, they're getting security on their data.
Brilliant. And we've got a session on security at 2 o'clock later today if any attendees want to hear about the cybersecurity aspect in more detail. So what proportion of universities are working in the cloud, and what are kind of the top 3 challenges they're facing in transition?
So the percentages is really difficult, because the modular nature of universities is a little bit difficult. So you'll have a core IT team who are responsible for effectively the university as an entity, but then the faculties themselves, and this isn't universal, but the faculties themselves may well be then autonomous in their own right. So they'll have their own IT team, they'll have their own IT budgets, and then what happens is you get a lack of control. So the framework that I discussed previously, or the landing zone, people are doing things differently, and there's no common rigor being applied to everything. So what my suggestion would be to try and bring all these environments under a common umbrella, as it were. You can still give them autonomy of their own budgets by using tagging and things like that. But what happens is they'd be under this overarching umbrella, but then still working in their key areas in the way they always have. Migration is always a real challenge. Never underestimate it. The more work you do before you start your migration, the better it'll be. It's just a huge amount of information that you just need to get right for it to work. And I think the key challenge is, or another key challenge would be, get an easy win that everyone can see, but isn't high risk. It's a bit of a niche one. So everyone can see that their life is made slightly better by working with cloud, and then people are more willing then to accept maybe it's a little bit of disruption further down the line. A key one would be Microsoft 365. It's relatively simple to deploy. People are using it. I used to using Outlook and Word and what have you, and actually when they get when their life is made slightly easier by using Office 365 and ability to work anywhere, they think, oh, well, actually, it may be worth a little bit of pain to get some more functionality like this.
Brilliant, thank you. And then the last one I can see at the moment, and again, Maxine, if you could have a look through in case I've missed any, is all the information in this presentation. As Jisc got a document that can be sent out to attendees to describe it all, we are also recording this session, so it will be available online later to catch up on.
We do have a lot of documentation, particularly in the cloud team. But if anyone would like to just reach out to the cloud team and want to have a discussion with us, I mean, we're more than happy to facilitate that, and then maybe we can have an understanding then of what people actually need, if need be, and that's something that we can tailor then to the specific needs of the organisation, because these slides have been shared and they are very high level, but I think to have more value, really, if you want to have a discussion around cloud, we need to really know what it is you're trying to achieve.
Absolutely, and I think that outcome-driven approach is really important when embarking on any IT change, but especially cloud, because we are talking about something that's new to a lot of people. So from a kind of cultural perspective, it's making sure that people understand why these changes are occurring. Fantastic. Thank you very much, Colin.
Thank you.
I'm going to hand back to Maxine to close us off for this morning.
Okay, thank you all so much. That was a really useful session for me personally. I feel it really good to have improved my very basic understanding of this area. I feel as though I've probably moved along the scale from not even knowing what I don't know to knowing what I don't know now. But it's really good to appreciate how it's relevant to my own organisation and to PraxisAuril members, and just understanding a bit more about how others need to work within your own organisations and how that might affect your own area of work is always good. So I hope you've all found some good takeaway points too. It's certainly demonstrated to me that we need experts in their field to run these sorts of services. But having said this, I'm delighted that I now know what a chaos monkey is. So yes, big thumbs up for that. Thank you so much, Colin. That was really really insightful. So if there are any further questions, then of course people can continue to communicate with us via all the usual PraxisAuril channels, and of course you can contact Caitlin or Christian or Colin directly too. The recordings will be made available to members shortly. We've got an online discussion forum where you can have a very topical sort of focused discussion. If you would like to continue that conversation, if you need any information about how to access that, then just use the chat to send for our team a note, and we'll tell you how to do that. So thank you again to Colin, Caitlin and Christian from Jisc, and to those who've joined us online, and I'll say hello as well to those people who will watch this watch the recording, and please also do feel free to contact us once you've done that if you have any further questions. So we'll wrap up. Thank you all. Our next session today is at 12 with Liz Bowell. She's Director of Open Research Services, talking about open access. And then, as we've alluded to already today, the final session of the day is at 2 with Guy Sardon, who's talking about cyber attacks. So for now, thank you all very much, and see some of you later on today.